So the review of index laws. First of all, I've by colour, I'm trying to find a way not to list the index laws by number, because if you start to talk to me about index law 4, well, different textbook has them different orders and it's meaningless. They're all arbitrarily numbered lists. So I've done it by colour instead. There are the 7 main index laws. The negative indices and fractional indices come with a whole bunch of side laws. They do it fractional indices with 1 over n and then m over n, and what if you combine negative with it. But these are the base laws. These are the ones I'll refer to. The first 2 are trivial. They're just facts that you should know. But then the next 3 are the simple index laws that you will have learnt in year 9. And the last 2 are the more complex ones you learnt in year 10. So these are your combined index laws that you should know, and I'll use them and refer to them by colour. So I'm going to go through the examples and just remind you of some of the things. I'm going to start with example 1 and just talk briefly through the laws we're going to use. The first thing we're going to do in example 1 is expand both brackets, raising an indice to the power of a value. That will be using the orange index law here, and I'll do that twice. We will have a negative indice involved, so that will be the blue index law, the dark blue index law, and then we've got to multiply here, so we're going to have to combine some indices by adding the power, so that'll be the purple index law. So example A is already going to be reasonably complex, and I'm pretty convinced I'm not going to get through all the examples already. But if I write down A quickly, 3a to the power of 4b cubed, all cubed, times 4a squared b to the power of 4 to the power of negative 2. I'm not actually going to really apply negative indices straight away. So I'm going to leave things hanging and I'll just change those negative indices at the end. So if I expand the first bracket, I get 3 cubed, a to the power of 4 times 3, might just zoom in on this while I'm doing it, and then b to the power of 3 times 3, times 4 to the power of negative 2, a to the power of 2 times negative 2, b to the power of 4 times negative 2. I'm slowing this one down, I didn't need those brackets. So this gives me 27, a to the power of 12, b to the power of 9, times 4 to the power of negative 2 is 1 over 4 squared. That's that negative power rule. A to the power of negative 4, I'm going to leave the negatives there for these ones. B to the power of negative 8. Now I get each term individually, the numerical term first. And you'll note here that 27 times 1 over 4 squared. 4 squared is 16, so it becomes 27 over 16. And then I get my A terms. A to the power of 12 times a to the power of negative 4. I add the powers, giving me overall a to the power of 8. And then I get my B term. B to the power of 9 times b to the power of negative 8. I add the powers again, it just gives me b to the power of 1, which I can just write as b. And that's it, that's fully simplified, numerically fully simplified, the best I can do. So I'll leave it like that. Just make sure that your 16 doesn't, your 6 and your 16 doesn't look too much like a b. Any questions on A? $81, 27, 35. B, 81. Anyone remember these powers? 3 to the power of 5. So B was 3 and 2, and it wasn't divide. Okay, so here's the next one, 3 to the power of 5 there. This is a numerical one, so you have to discern between the algebraic and the numerical ones, and you have to be good with working with the numbers. You could get these questions, although I have said we won't push too far on index laws as an individual topic in the exam, but you could get these questions as standalone questions in your external exam tech-free. So if you saw this in a tech-free exam, it would be really handy if you recognised that 81 and 27 are special numbers. I've actually added onto this these values here. Here they are. And I talked about this with my Year 10 class last year. These, in no way am I suggesting you should memorise these lists, but if you recognise these numbers, it's going to make your life a lot easier. So if you see 81 in one of these questions, you're like, oh, 81 is one of those special numbers. I think it's a power of 3. You can quickly work out what power of 3 it is. You just have to recognise and be able to recall those numbers exist somewhere. So just be aware of them. 81 and 27 fall in this powers of 3. I had a massive hint in the fact that the question had a base 3 in it already. So I'm expecting these numbers to have base 3 properties. So I get 3 to the power of 4 cubed divided by 3 cubed, squared, over 3 to the power of 5. And that gives me 3 to the power of 12. If I've got power over power, I multiply those powers. Divided by 3 to the power of 6 over 3 to the power of 5. When I divide two indices and they've got the same base, I subtract the powers. That gives me 3 to the power of 12 minus 6 over 3 to the power of 5, which gives me 3 to the power of 6. I'm flashing this one out pretty big as well. And again, when I divide powers again, so this is just a different way of dividing, I subtract the powers and that gives me 3. 3 to the 6 minus 5 is just 3 to the 1, which is just 3. So that question works out quite nicely, purely by design actually. But again, it's just about knowing those 81-27 rules.